Okay, so in this video, we're going to look at what's called a determinant. And a determinant is it's like a measurement or a way to describe matrices. It's a quality or a characteristic of a matrix. And that's going to allow us to, or one of the, I guess, applications is it's going to allow us to solve a system of equations in another manner. And then as you move on in mathematics, a determinant also is used in more matrix theory, more algebra theory. So it's a great, again, it's just kind of like an introduction to one of the things about matrices. Now, not every matrix has a determinant. Only square ones do. So as I start filling out this sheet, some of the things I want to keep track of is that only square matrices will have a determinant. Okay, so if you don't have a square matrix, for example, if your matrix is like 2, 3, 4, 7, -1, 2, 8, 16, 0, 3, 0, 1, because that's a 3 rows by 4 columns, right? That's a 3 by 4. That will not have a determinant value. Okay. Now, if you have a square matrix, but 2 of the rows or 2 of the columns are identical, that means your determinant will be 0, because if you have 2 rows that are exactly the same, you could subtract one from the other and you get a complete row of zeros. So the measurement of the determinant, and again, it's kind of like we haven't determined what that is yet, but that determinant is equal to 0. Okay. If you take a row, and you multiply by some constant. So if you multiply 2 row 2 and put it back into row 2, right? And assuming you have a square matrix, then that's going to multiply the determinant by 2 as well. It's just going to double it. So multiplying a row by a constant changes the determinant by that constant, right? By multiplying by that constant. By multiplying by that constant k. And if you switch the order of your rows, or in columns too, it doesn't really matter, that's going to make your determinant off by a factor of a -1. So every row switch changes it by a factor of a -1. By a factor of -1. Okay. But if you do a standard row operation, and maybe instead of saying standard, I should say like a linear combination. So like, remember, like a linear combination would be like 2 row 3 plus row 4. Put it into row 4. If you do that, it doesn't change the determinant. Okay. So linear combination of row operations do not change the determinant. Okay. So a lot of these are just like, just things that you'll eventually kind of get to know about determinants and about the matrices. But right now, let's look at finding determinants by hand with a 2 by 2 or a 3 by 3. So finding a determinant of a 2 by 2, so 2 rows, 2 columns, and this DET is one way to give give that operation of finding the determinant. So what you're going to do is you're going to take those 4 entries, right? Just so you have 12, 4, 1, 3. And the rule for and this only works for a 2 by 2, is you multiply down this diagonal, and then you subtract multiplying down that diagonal. So I do like 12 times 3 minus 4 times 1. Okay, and so that's equal to what? 36 minus 4, which is 32. Okay, so that's not a matrix. That's a value that we'll use to help describe this particular matrix, or this matrix, I should say. This matrix has a determinant value of 32. If you think about like the positions of these numbers, like if this is like in the A, B, C, D position, then the determinant of this matrix, any 2 by 2 would be AD minus BC. You go down this diagonal and subtract this diagonal. Okay, so some textbooks like define it like that. Now, if you don't see DET as the operator, but you see something like number 2, where it looks like it's like oversized absolute values, right? Notice that the little hats and feet, so to speak, are missing. that's another way to indicate find a determinant. So if you happen to notice that your matrix doesn't have the hat and the feet, then you know you're looking for the determinant. So I would do the determinant of this matrix is 2 times 2 is 4 minus negative 3 times 10. So 2 times 2 minus negative 3 times 10. And be really careful about that subtraction. Just like a lot of times, like that's an easy place for a student to accidentally make a mistake. So it becomes 4 plus 30, which is 34. That's a terrible 4. That one's better. Here, 6 times 2 is 12 minus 4 times 3 is 12. So I get 12 minus 12, which is 0. Now, the determinant of 0, that should indicate that there was probably a row that was identical, or in this case, a scale factor. Because think about like 6 times 4, 6 4 is double 3 times 2. So if you would have done half of row 2 or half of row 1, or even doubled row 2, notice you have identical rows, and so you know that the determinant would be 0. So just a heads up on that. Okay, now, unfortunately, that process doesn't work for 3 by 3. So the process to find 3 by 3 determinants is the following. So I'm going to rewrite those entries. 1, 4, 3, 2, 0, negative 3, negative 1, 1, 2. And what I'm going to do is I'm going to rewrite that first column of 1, 4, 3 right next door. And the second column, 2, 0, negative 3. So I'm just copying those columns next to them. And that's going to allow me to go, it's going to allow me to kind of mimic this guy going down the diagonal, but you're just going to have to go down all of the diagonals. So what I want to do is go down this diagonal. So 1 times 0 times 2. And then I want to go down this diagonal, 2 times 1 times 3. And then I want to go down this diagonal, negative 1 times 4 times negative 3. So I want to go through all of those. So 1 times 0 times 2, 1 times 0 times 2, plus 2 times 1 times 3. And obviously you could do a lot of this in your head, but I'm just writing these down so you can see it, plus negative 1 times 4 times negative 3. 4 times negative 3. So I'm gonna add all of those up. So 1 times 0 times 2 is 0, plus 2 times 1 times 3 is 6, plus negative 1 times 4 times negative 3 is 12. So the entire side is equal to 18. And then I'm going to go in the reverse direction, just like the 2 by 2, how we went down one way and then we subtracted this way. So the same idea. I'm going to go down this way, down this way, down this way, and I'm going to basically be subtracting those values. So 2 times 4 times 2 is 16, plus 1 times 1 times negative 3, so negative 3, plus negative 1 times 0 times 3, which is 0. So 16 plus a negative 3 is 13. So I'm subtracting 13, which is equal to 5. So again, you know, for 3 by 3, you just kind of, you create 3 basically diagonals, and then you subtract the diagonals that way. And that's the process for 3 by 3. And then 4 by 4 is different, and 5 by 5 is different. So by hand, I will only ask you to do a 2 by 2 and a 3 by 3. Then if you ever needed to go a larger one, we could go, use our calculator. So again, let's just do one more example here. If it's a matrix that doesn't have the hat or the feet, right, that doesn't have these guys, then that's the symbol to find a determinant. So I'm going to find this determinant. So what I can do is I can just copy this column next to it. Maybe I'll use another color here. I'm thinking nice purple. So 2, negative 1, 1, and then copy this column, 3, 1, negative 3. And again, what I'm going to do is going to go down that diagonal. That color, there it is. So 2 times 1 times 2, which is 4, plus 3 times 0 times 1, so that'll be a 0. And then 4 times negative 1 times negative 3 is a 12. So again, that's 4 plus 0 plus 12. Then I'm going to take away going in the other direction. So 3 times -1 times 2 is -6. 2 times 0 times -3 is 0. Oops, sorry, there it is. And then 4 times 1 times -1 is -4. So I have 4 plus 0 plus 12, which is 16, minus -4 plus -6 plus -4 is -10, and it's a minus a negative, so it becomes a positive 26. Okay, and I did say we don't have to do like a 2 by 2 and 3 by 3 by hand. And just to make a point of reference here, number 5, if I ask you to do this without a calculator, there's probably some trick to it, right? And the trick is, or I guess the test is, do you recognize or do you see that this row right here is identical to this row right there? And when you have 2 rows that are identical, regardless of the dimension, right, regardless of the size, as long as it's a square matrix, which I have, a 5 by 5, if 2 of the rows are identical, then your determinant is equal to 0. So really there is no work here if you recognize that. Okay, so go back and just double check, but really the goal of this video was to make sure you know how to find a determinant of a matrix if it's size 2 by 2 or 3 by 3, and then know that if you have 2 identical rows, the determinant would be equal to 0. And then there are some rules about what happens to determinants if you start doing row operations. Switching rows to get that factor of -1, or multiplying a row by a constant would also multiply the determinant by that constant.